idea of what a sampling distribution is and kind of how we would make one if we were doing it with a really small population. Okay, so our population is just 2, 6, 8, 10, 10, and 12. So imagine that these tiles were in a bag, right? And and we know that this population, it's telling you the mean of this population. So if you added 2 plus 6 plus 8 plus 10 plus 10 plus 12 and divided it by 2, 4, 6, you'd get 8. And the range is 12 minus 2, right, is 10. So it's telling you here's the population. Now, we're going to have simple random samples of just 2 at a time from this population. And because it's so small, we can list all 15 possible random samples. So we can just say, we're going to look at, right, what would be possible, right, if we were only taking 2 at a time. Well, we could pull a 2 and a 6. The mean of 2 plus 6 is 4. We could pull a 2 and an 8. So they're just going 2, 8, 2, 10, 2, 10, 2, 12, right? And getting the mean of each time. And going through then 6, 8, 6, 10, 6, 10, 6, 12. So what are the 15 different samples we can get? And this is telling you, and in brackets is the mean because it's asking you every time you sample 2, what mean do you get? So that's this first part, A. And then it says, well, what would the graph look like, right? If you graphed all those means. So the mean of 2 and 6 was 4, so I have 4 on here. The mean of 2 and 8 is 5, so I have 5 here. The mean of 2 and 6 is 6, and here you have here. And then it says, well, what does this look like? Well, this is the sampling distribution of X. It's skewed a little bit to the left, right? Because it's got these smaller values, even though more of them are over here, right? It's unimodal because it has one mode. The mean of the sampling distribution, well, if we added all of these up and found the mean, we'd find that it's 8, which is interesting because that was the same as our mean of our population, right? And the values vary from 11 to 4. Right? So what it's asking you to kind of think about here is when we start to sample many times from a population, we come up with this idea that, wow, even though we're sampling a smaller number, we're going to end up with, right, we're talking about what was a biased and unbiased estimator. So we see that the mean of the sampling distribution is an unbiased estimator of our population. All right, I hope that helps you see how this problem was set up. If not, let me know. I'll try to explain better.